Ever feel like you're looking at this incredibly complex dashboard, maybe like a spaceship cockpit? When someone brings up Google BigQuery, you know it's powerful. You want to get your head around it, but well, where do you even start without feeling totally overloaded?
Yeah, that's a common feeling. And it's understandable.
So that's what we're tackling today.
Exactly. BigQuery is, it's really fundamental now, a real workhorse for pretty much anyone dealing with data analytics.
Right, engineers, analysts.
Yeah, engineers managing pipelines, analysts finding insights, data scientists building models, even, ML folks and the leaders guiding the strategy. Getting the basics is, well, it's not just nice anymore, it's pretty essential.
Okay. So our mission for this deep dive, then, is to really boil down the absolute must-knows, the foundational bits of BigQuery. Like a quick start guide, whether you're just dipping your toes in or maybe leading a team that uses it day to day.
Perfect.
All right, so to get us started, where does everything actually live in the BigQuery world?
Okay, so the absolute foundation is the Google Cloud project. You really have to think of it like a dedicated digital workspace.
A workspace, okay.
Yeah, for your team, all your resources. It's the big container holding everything, handling security, organization, all that.
Got it, a digital workspace. And inside that space, how do we start organizing the, the actual data?
So within a project, you have things called datasets. They're basically logical containers. Think of them like folders on your computer or maybe schemas if you come from a database background.
Okay, folders or schemas, that helps.
Yeah, they just help you group related tables and views together logically, keep things tidy.
So projects contain datasets, and I guess datasets contain the actual data.
The data itself sits in tables. These are structured, columns and rows, just like you'd expect.
Right.
And they live inside your data sets, like a massive spreadsheet, potentially holding petabytes of data.
Wow. Okay, so we've got the structure. Now, when we want to actually do something with that data, what happens?
Oh, okay. So any action you perform, basically anything you ask BigQuery to do.
Like running an analysis.
Yeah, running a query or maybe loading new data in or exporting results out. Each of those is executed as a job.
A job.
Yep. Every time you click that run button in the interface, you're kicking off a job. It's a task happening within your project.
Okay, got it. Every click is a job. And the language.
Yeah.
How do we tell BigQuery what job to run?
Right, that's where Google SQL comes in. It's BigQuery-specific SQL dialect. It's very powerful.
So it's SQL, but tweaked for BigQuery.
Pretty much. It handles all sorts of data types, even complex stuff like nested fields or geographical data. If you know standard SQL, you'll feel right at home, mostly.
Yeah.
But it has extra features built for big data scale.
Okay, Google SQL. And we use that to write queries, right? What's the main point of querying?
Querying is, well, it's how you get answers from your data, how you find insights. The main tool is the select statement. That lets you filter down to just the rows you need, group things together to calculate sums or averages, join data from different tables.
Combine different data sets.
Exactly. And order the results so they make sense. It's all about turning that raw data into something useful, something actionable.
Now, I've heard BigQuery has this kind of clever architecture, something about separating storage and compute. Why is that such a big deal?
Oh, yeah, that's absolutely key, especially when you're dealing with massive amounts of data. BigQuery uses Google's huge scalable storage, which is pretty cost-effective just to hold your data.
Okay.
Then, when you run a query, it spins up the processing power it needs for that specific job.
Ah, so it's not always on.
Exactly. You only pay for the compute, the analysis power, when you're actually using it. You avoid paying for powerful machines sitting idle, which you might have to do with more traditional systems. It's way more efficient and usually cheaper for cloud-scale analytics.
Right. That makes a lot of sense for controlling costs.
Yeah.
So where does that processing power come from? You said it spins up.
Yeah, that's where slots come in. You can think of slots as units of computational power.
Units of power. Okay.
BigQuery uses them under the hood to run parts of your query in parallel. You don't really manage them directly, but basically, the more slots available to your query, the faster it runs. Complex queries or queries over tons of data, they just use more slot time.
Got it. Slots are the engine power. Now, what if you have these absolutely enormous tables, like billions of rows? Is there a trick to making queries faster and cheaper then?
Yes, definitely. That's where partition tables are super useful. Imagine you have a giant log table. You can tell BigQuery to split it up, maybe into daily chunks based on a date column.
Okay, like virtual smaller tables.
Sort of. When you then query, say, just for yesterday's data, BigQuery knows it only needs to scan that one specific partition, that one chunk.
Instead of the whole massive blank.
Exactly. It dramatically speeds up the query and, crucially, reduces the amount of data scanned. Less data scanned means lower costs. It's really important optimization.
Partitioning sounds essential for big data sets. Okay, so we've covered quite a bit. Projects as the workspace, data sets for organizing, tables holding data, jobs for actions, Google SQL for the queries.
The separation of storage and compute, slots providing the power, partitioning for efficiency.
Right. One last piece.
Yeah.
How does the data actually get into BigQuery in the first place?
Loading data. Yeah, several ways to do that. For small files, you can often just upload them through the web interface, the cloud console.
Simple enough.
For bigger stuff, a really common pattern is putting the data into Google Cloud Storage first, that's Google's object storage, and then loading it into BigQuery from there.
Okay, like a staging area.
Exactly. And you can automate all this too using scripts or data pipelines for regular updates. The best method really depends on, how much data, how often it arrives, where it's coming from.
Okay, that covers the main building blocks then. Projects, data sets, tables, jobs, Google SQL, storage compute, slots, partitioning, loading. Feels like a good foundation.
It really is. Those are the core concepts.
So let's make this real. Imagine a new data analyst joins a company using BigQuery. What might their first day or first task look like using these ideas?
Okay, yeah. So day one, they probably get access to the company's Google Cloud project. They'd log into the console, navigate maybe to their team's data set. Let's say it's called sales data.
Right.
Inside, they'd see tables, maybe one called transactions. A common first task might be, hey, can you pull the sales numbers for the last week?
And even with just basic SQL skills, knowing about jobs.
Exactly. They could write a pretty simple Google SQL query, select from salesdata.transactions, where transaction date, some date, maybe add a limit in 100 just to see what the data looks like.
And they hit run.
Which kicks off a BigQuery job. It processes, returns the results. They can even see info about the job, like how much data it scanned, how long it took. It's this immediate ability to query, even with simple SQL. That's so powerful.
Yeah, gets them productive quickly. And thinking about team leads or managers, why is it important for them that their team understands these basics?
Well, it really helps build data literacy across the team. It empowers more people to ask their own questions of the data directly.
Reduces bottlenecks.
Totally. Less waiting for a dedicated analyst for every little thing. It breaks down silos, allows for quicker exploration, faster iteration on ideas. Ultimately, it just makes the whole team more productive and, data-driven.
So really, whether you're the analyst just starting out or the leader aiming for efficiency, getting a handle on these fundamentals, project, dataset, table, job, Google SQL, partitioning, loading, it's the necessary first step.
It's the launch pad. Everything else builds on this foundation.
Okay, so a final thought maybe for you listening. Thinking about these core concepts we just covered, how could understanding them right now change how you approach a data task you have? Or maybe help your team work more effectively?
Yeah, what's one small question you could try to answer using BigQuery today, even with just this basic understanding it's worth thinking about?